working on for the past 1 month. The title, as you can see, is leveraging Lidar data to quantify the complexities in autonomous driving. So what do we mean by complete autonomous driving? For me, it's zero human involvement. And so far, I don't think we have reached that. So what are the ways to improve the current models? And that is what we have been working on. We are using advanced sensing technologies, LiDAR being one of them, to understand the driving conditions that include the road terrain. You wouldn't want to drive in a pothole, right? Knowing what the traffic signs are and what are the lane widths, so that the future generations of the autonomous driving models can take better decisions and not have any critical errors while we operate on fully automatic mode. We have been using the Ouster OS1 LiDAR model. It is the latest in the industry in terms of sensing. It has a range of up to 200 meters and 45-degree angle. And it collects about 5.2 million samples per second. So you can understand how much detail we are getting from it. We are using the data we gather from the sensor to process it, and then use that to make better decisions. So far, we have been able to classify different objects on the road using a thing called semantic segmentation. What it does is it classifies the LiDAR points within the point cloud that looks something like the image on the right side, and it detects what kind of object is there. Sort of like image processing, but in a way better manner. And we have also created a proprietary transformer model that will infer what the particular object is in the point. Now my friend Aaron will share more about the transformer.
Yeah, hello, myself Aaron Nazareno. So for this task, for semantic segmentation, we are using the point transformer version 2 model. As you can see the architecture, we won't be going too much in detail, but so what it does is we have the LiDAR point cloud data, as you can see on the top, and based on it, we basically using a deep learning model, I would say, a deep learning framework of the transformer version 2 model. We basically classify these, you can say, different this environment, you can say the highway environment, into different features. Basically, we classify them into different classes like lane, vegetation, traffic signals, and light poles, and etc. So how do we do it? We have the model basically uses for each and every point, it has a spatial coordinate and it has particular intensity value, and based on it, it determines how these points in the point cloud are related to each other. And based on that, we are basically able to classify different features of the environment into different classes. So what does it do? It makes our work of manually segmentation. Like if a human does this segmentation, it takes a lot of effort, but using this automated, I guess, say, method, using AI and artificial intelligence and machine learning, it makes this process much easier and very fast. That's what we are basically researching on. This is this will make the as you all know, autonomous vehicles are something which are very to be prominent in the future, and this research will be surely very helping. It will be helping it a lot. So that's, and not only autonomous vehicles, it would be big data analytics and all regarding transportation engineering. So it would be a great, I would say, this is which would be obviously quite helpful for those folks. Yeah, that's all. Thank you.